Musk's level of crazy is completely beyond anything we Earthlings can imagine. He's practically dragging humanity toward a Type 2 civilization. This time he is genuinely aiming to build a massive Dyson Sphere-like concept right out in space. Just between December 25th and 31st, 2025, the China National Space Administration declared 203,000 satellites to the International Telecommunication Union, ITU. Immediately following that, on January 30th, 2026, Elon Musk submitted an application to the FCC that likely sent shockwaves through the Pentagon. SpaceX has officially applied to launch and operate 1 million satellites. If he actually gets his wish and deploys 1 million satellites above the Earth's surface, will we even be able to see the sun? What exactly is the point of Musk launching 1 million satellites? Today I'm going to break it all down for you. Just recently, reports surfaced that Musk is considering merging SpaceX and XAI and taking the combined entity public. This could potentially be one of the most impactful IPOs in human history. Estimates suggest that post-IPO, the company's valuation could hit $1.5 trillion, a figure nearing the entire annual GDP of Australia. With that kind of massive capital, Musk would finally have the financial firepower to go full throttle on his Dyson Sphere plan. Do we really need to launch that many satellites into space? Actually, Musk is applying his first principles thinking again here. While XAI hasn't shown any particularly dazzling highlights among the currently hyped AI technologies, that doesn't mean Musk is willing to fall behind in this race. He is planning for a much grander goal. The biggest bottleneck in the AI industry right now isn't chips or GPUs, it's electricity or energy. You have to realize that on Earth, training a model like GPT-5 consumes as much power as a mid-sized city, not to mention the millions of tons of fresh water needed to cool the servers. China has already planned to build its own supercomputing centers in Xinjiang. According to normal logic, the US should also build its own massive supercomputing centers, ideally located near clean energy sources like hydroelectric or solar power. But if Musk did that, he wouldn't be Musk. Let's shift our perspective to space. There's no atmospheric interference, solar panels are 5 to 10 times more efficient than on the ground, and they can run 24 hours a day without interruption. Furthermore, the background temperature of the universe is close to absolute zero, providing a natural superconducting environment where heat can be efficiently dissipated through radiation. The 1 million satellites Musk applied for are essentially moving the high-energy consumption, AI inference and training processes from Earth to space. The extreme heat dissipation efficiency allows for maximum density chip stacking. These aren't just 1 million satellites, they are practically 1 million H100 graphics cards with wings. This is a dimensionality reduction strike against terrestrial players. These AI satellites have no electricity bills, no cooling costs, and utilize free space energy for computing. They just need to beam the calculated results back to the ground. It is simply the ultimate energy arbitrage. Moreover, the communication advantages in space are something ground-based systems can't touch. Take our commonly used fiber optics. Light has to wind its way through the cables, and the refraction causes latency that slows down information transmission. But Musk satellites use lasers to communicate in space, effectively taking the cosmic express lane, achieving absolute limit speeds. Imagine if Musk really completes the launch of 1 million satellites, this could become Earth's biggest brain. And the longer it's used, the lower the cost becomes. Of course, some people will ask, doesn't launching satellites cost money? According to reports, SpaceX's revenue in 2025 is estimated to reach $15.5 billion, and while profits didn't quite hit $8 billion, the profitability is robust. The IPO valuation is rumored to exceed $1.5 trillion, and Musk plans to raise $50 billion. June 28th is Musk's birthday, and it's very likely he'll gift the IPO on that day. Currently, Starlink is the world's largest satellite operator, with over 9 million broadband users as of December 2025. In addition, commercial contracts from NASA and other nations, along with the Starshield military network, provide Musk with extremely rich cash flow. With this massive pile of money, Musk has developed another crazy steel beast, Starship. Currently, the Falcon 9's payload capacity in reusable mode is about 15.6 tons, and in one mission, it loaded as many as 24 Starlink V2 mini satellites. But the latest V3 Starlink satellites are expected to weigh around 2 tons each, with bandwidth soaring to 1 terabyte, more than 10 times that of the current V2 mini. Whether it's loading V3 Starlink satellites or launching dedicated AI satellites, Musk needs a bigger, stronger Starship. The latest V3 Starship is expected to deliver 100 to 150 tons of payload to low Earth orbit and is fully reusable. At that point, it's no longer just a rocket, it's a sky elevator shuttling between heaven and Earth. We can just do a simple calculation. If Starship technology matures and the launch cost drops below $10 million, with a single load of 100 tons, the shipping cost per kilogram is only $100. Isn't that basically floor price? Not only is the price low, but a single Starship launch could carry hundreds or thousands of microcomputing satellites. It's simply mind-blowing. There is a terrifyingly effective commercial loop here. SpaceX is now fully profitable, and Musk is using a model where Starlink feeds Starship, and Starship carries Starlink. turning the high and mighty aerospace industry into something akin to the logistics industry. Musk's progress is so rapid that many people are expressing concern. Aside from commercial purposes, Musk's satellite launches are also a space enclosure movement. According to International Telecommunication Union (ITU) rules, Earth's orbital resources and frequency resources follow a simple, brutal principle: first come, first served. Although low Earth orbit is vast, space is also very limited. Low Earth orbit mainly refers to the space 500,2000 kilometers above the ground. According to some scientists' estimates, the safe capacity for satellites in low orbit is about 72,000. If Musk really deploys 1 million satellites there, any country wanting to launch satellites in the future might have to report to SpaceX in advance and ask them to clear some precious orbital space. Wireless spectrum is also a non-renewable natural resource. Musk's application this time basically occupies the key frequency bands that future 6G and satellite internet might use. Not only that, but high-density satellites could very likely trigger the Kessler syndrome in space. Once object density in space gets too high, a single collision could generate thousands of fragments, which then trigger cascading impacts, eventually forming an impenetrable barrier of space junk that could permanently lock humanity on Earth, making us prisoners of the surface. This isn't alarmist talk. Both the International Space Station and the Chinese Space Station have encountered incidents of being impacted by space debris. 1 million satellites. This could be the cornerstone that Musk uses to lead us toward a new civilization, but it is equally fraught with risk. One slip-up, and it could lock humanity on Earth. We are standing at a turning point in history. I hope you'll share your thoughts in the comments section, subscribe to me and hit that like button. This is my motivation to keep creating. Thank you.